Hi everyone, welcome back to Rust programming tutorials. Today we are going to talk about multi-threading or concurrency in Rust programming. So it's not a new concept. Every programming language offers you to concurrently allows you the facility to concurrently execute multiple codes by using threading or multi-threading, which we also call it as concurrency. In Rust, you create a new thread by using the keyword spawn. Okay, so thread :spawn. Notice something, you got to import the library, which is in standard thread, and you pass it. We're going to talk about these double parallel lines in just a minute. But what you do inside it, you write the code which is supposed to be executed in the newly created thread. So this is just a simple example wherein we are running in a for loop and we are printing the value of I. And the next is here thread.sleep, and we make the thread sleep for 1 milliseconds. What it does is basically sends this thread, whichever is executing this print statement, into background and let the other thread come back forward or use the resources. Then we print something here, and then we again send this back to sleep. So this one comes back. So that's the thread.sleep, so that it goes back in the queue for the resources and let the other thread which is there in the queue execute it. Okay, so this is how it is multi-threaded programming takes place. It's not like all the threads are executing at once. Each one does one task, goes to sleep, and the other one comes up, goes to sleep. Like that, they share resources. I will show you the example of move keyword. So what happens is, since you're creating a new thread, a new separate thread, if main had certain variables which this thread needs to use, again, we are going to see it in an example, we'll have to use move keyword so that the ownership of the variable moves into the thread. Okay. Now coming back to these parallel lines. What are these parallel lines? They are actually called as closures. They are anonymous functions, or in some languages, we also call them as lambdas. So they are anonymous functions which can be assigned to a variable, and it can be even passed to a function as a parameter, can be assigned to a variable, executed, different context. So see, here is an example of assigning the function to here. Okay. Now, notice this X inside it. So what it does is, this means that this lambda is returning a value. This anonymous function is returning a value. So if your anonymous function or the lambda has to return a value, it has to be written within this parallel lines. So it just, what it does is example closure, whatever you pass it, it just returns it. So what you're doing is example closure, you're passing the parameter hello, and S will have value hello. So these are closures. You can read about it. Now let's go and see some threading in action. Okay, here you go. All right. So here, this is the first example that we saw. 2 threads. One, the child thread, which we are creating using the spawn keyword. And we are going in the loop 10 times, but every time we print a number, we are going back to sleep. Then next, this is the main thread, okay, which itself, main program itself runs in a separate thread, okay, the crate itself. And then let's see the output of this one. So these are the other some examples which we are going to try. So what we would expect is, okay, this one will print till 10 and this one will print till 5. But let's see what happens. So we'll do cargo run here. Now see here. So it printed one from the main thread and then one from the child thread. Two from the main thread, two from the child thread. Three. But notice here, it stopped at 6. Okay, it stopped at 6. We were expecting it to run till or print till 10, but it did not. It stopped at 6. What happened? What happened was the main thread finished its life. The life cycle of the main thread, the main creator, ended here after 5 repetitions. There's nothing for this thread to do. So the main function died. So when the main dies, all the child threads are cleared or they no longer exist. Okay. But what if we want the main thread to wait? In case if we want the main thread to wait, then we have the join function available. Now see what happens. So join makes the main thread wait until all the child threads are finished. Okay, so let's see here what happens. In the scope, what happened here? Oh, here. I haven't defined the handle because I'm using handle, but handle hasn't been defined. Here you go. Now see here. Now one from main, one from spawn, and see the main thread is finished here, but still it continued and went on till it finished 10 times this, right? Because you started from I, 1 to 10, okay? And then it finished here. So that's how it is. But again, see, it was going once in the main, once in the spawn. Then see, first it started with main, then main went to sleep, then it went to the spawn thread, then the spawn thread went to sleep, then again it went here. So that's how they were sharing the resources. But if I move this here, okay, what happens? Now see the difference. What happens? Because handle joinery does not implement copy transit. Okay. So we cannot move it here. Okay. So it's not allowed. Oh, there are two. Sorry. Here. There you go. Now here, now notice the difference. See, in the previous one, you had one from main, one from spawn, one from main, one from spawn. But here, what this join, because it's here, it completely first executes all the commands that are there or all the steps that are there in the spawn thread, and then it goes to me. Okay, so that's a big difference where you put the join. Or join is basically wait until something is finished. So in this example, what happens? The code comes here. It says, oh, we have to wait until the join is done. So it waits, or until the first thread is finished. The handle is finished. Now this was about the join. Now the move keyword. Okay, so let's get rid of this code and let's try this first. Go here and first let me remove the move keyword. So basically what we are doing, we have defined a vector and we are printing it in this thread. We are passing the variable which was declared in the main thread to the child thread. So remember, main itself has a thread. Main itself runs in a thread, separate thread, then the spawn thread. Now, what happens is there is a risk. What if we do something to V here after the statement. Okay, it won't, you could very well delete this vector or update the vector while this is still referencing. So Rust will not allow you to do that. You will have to put a move keyword before the closure. Okay, so that we are specifying to Rust that pass the ownership of this vector to this thread. This thread will now own the entire ownership of V after adding move. Okay, but let's see now what happens. See here, because what it says is may outlive the borrow value V, because you could do anything to V here after the statement, but the thread can outlive it. The thread might still be active. Then what to do? So Rust does not allow you. So it suggests, so add move here. Okay? So you need to add move. And then it's going to print just fine. And here it is, the vector 1, 2, 3. You see the output? Here's the vector 1, 2, 3. All right. So this was a short video explaining how to use concurrency, how to create a new thread. In the next lecture, we're going to talk about how to communicate between two threads using messages. Okay. In Rust, two threads talk to each other using messages. So that is what we are going to see in the next lecture. So just a brief recap. So you have to use std standard thread package. Duration is for the sleep. You create a new thread using spawn. These double parallel lines are closures or anonymous functions. And to an anonymous function, you can pass a parameter 2 if it has to return a value. Join on the variable which holds the reference to the thread makes the main thread wait until the spawned thread is finished or completed execution. Okay. The output will differ where you're putting the join. If it's at the end, it will execute all the threads one by one and then wait for all the threads to finish, or rather the handle to finish. Okay. If we move the handle here, like between these two, it will first execute the the first thread, and then it will go to the main thread. Move statement moves the ownership of the variable which from main to the spawn thread. Okay, that is all for today. Thank you all for listening, and see you all again in the next lecture with more multi-threading. Until then, keep revising. Thank you. Bye.